Hello class, welcome. So this video is for the explanations of exercise 2, 3, and 4 that we were not able to perform last class. So here we go. Exercise number 2. This problem says the following. A person walks around a circular track once. This track has a radius of 10 meters. Calculate the distance traveled and the displacement of this person. So let's start. Remember, if we're talking about motion, we necessarily have to set a frame of reference, which is this. It's basically a Cartesian plane. This is what we understand as our frame of reference in physics. And this is the origin, right? This point here, this is the origin of my frame of reference. Remember, this is useful because once you have this, you can talk about the position of any object in this Cartesian plane, whether it's moving to the right or to the left or north and south, etc. Now you can talk about motion. Okay, let's continue. So what is my particle in this case? It's a person. So I'm going to put that person at the origin of my frame of reference. And I'm going to start to move this particle in the same way that the problem tells me. So this person walks around a circular track once. So basically this person is following this path. So circular path. And this person will arrive at the same point that he started with. Why? Because it completes a full, like it walks around the circle once, just once. So obviously he has to go back to the same starting position. Okay, so the initial position and the final position of the motion are both the same. They coincide. The initial position of the motion and the final one. They are exactly the same. Okay, so how can we calculate the distance traveled? What would be the distance traveled by this person? Well, basically it's going to be the circumference or the perimeter of this circle, right? And we know that the circle has a radius of 10 meters. So this is the center of the circle, this is the radius, okay, and we know that this is 10 meters. If you remember, the formula for getting the circumference of a circle is 2 pi r, and r is the radius of such circle. So in this case, the full circumference will be 2 pi times 10 meters. So take your calculator and please calculate that number, 2 times pi times 10, and you will find that it's approximately 62.8 meters. So that's basically the whole distance traveled by this person, 68.2 meters. It's an approximation, so we should write this symbol, guys. Distance is approximately 68.2 meters. Okay, very good. Now, what about the displacement? Remember, the displacement means the length of the straight line joining the initial point and the final point. But in this case, since the initial point and the final point of the motion coincide, then clearly the displacement has to be 0 meters, right? Because this person went back to the same initial position. So there is no displacement. The displacement is 0. This is perfect. There is nothing wrong with this calculation. And in this case, we cannot add any direction to the displacement, right? Because there is no, I mean, really, there is no arrow. For example, if this was the initial point of the motion and this was the, let's suppose this was the final point, then you could trace the displacement in this direction. And so this arrow does have direction, but since there is no displacement, it's 0, we cannot assign any direction to this type of displacement. So just saying 0 meters is perfect in this particular case. Only in this particular case when the displacement is 0 meters. And that concludes this problem. Let's move to the second one. I'm sorry, to the exercise number 3. In this problem, we have a car that travels west for 10 kilometers and then south for 4 kilometers. Same questions. Find the distance traveled and the displacement. So let's draw our frame of reference. This is the x-axis, the y-axis, or you can also interpret this as being north, south, east, and west. And my particle in this case is a car. Let's put that car at the origin of my frame of reference. There you go. And then I'm gonna start to move my particle as I'm told. It's gonna travel west for 10 kilometers. So west for 10 kilometers. There you go. I'm gonna represent that motion in this direction, and this arrow has a length of 10 kilometers. And then the car is positioned right here at the moment, and it's gonna move south for 4 kilometers. So let's represent that motion, guys. There you go. It's gonna be a shorter arrow, and this arrow has a length of 4 kilometers. So it's gonna be 10 kilometers, 4 kilometers, and then it's gonna stop right there. Okay, perfect. So this is the initial position of the motion, this point, and this other point, the tip of this arrow, right, this point, it's the final position of the motion of the car. So let's draw the displacement. Remember, the displacement is the arrow going from initial to final point in that specific direction. You cannot draw it from final to initial. If you did this, guys, from final to initial, that would be wrong. This is wrong. This is right. That is the displacement. This blue arrow is the displacement of the car. Okay, now let's solve the questions. What is the distance traveled by the car? Clearly, it's 14 because it's going to travel 10 and then 4. That is the whole distance traveled. So distance is going to be equal to 14 kilometers. This is a scalar quantity, so it doesn't need direction, and this is complete. Now let's talk about the displacement. How do I calculate the displacement of the car? Well, the displacement is the length of this blue arrow. And if you notice, guys, what we have in here, mathematically speaking, is a right triangle. Can you see? This is a right triangle. This is one side, this is the other side, and this is the hypotenuse. So whenever you have a right triangle, you can use Pythagoras in order to calculate any of its sides. In this case, the hypotenuse. We need the length of this blue arrow because that length is the displacement, and that length happens to be the hypotenuse of this triangle. So let me represent the length by x, by a variable x. And so we have that, according to Pythagoras, x squared is equal to 10 squared plus 4 squared. I am ignoring the units for simplicity. So let's do it. This is gonna be, all of these will be 116 when you calculate it, all of this. And then just let's take the square root of 115 with your calculator. You will get 10.77 approximately. So the displacement will be approximately 10.77 kilometers approx. And in what direction? Well, let me erase this because we don't need it anymore. The direction, guys, in this case, the direction of this displacement, this blue arrow, we will say that it's in between west and south, because it's somewhere in between the west and the south, clearly, right? Sometimes we will say something like this, southwest. We can say this, or we can also say somewhere between west and south. Like, we're not gonna be very precise, guys. To be honest with you, the way in which we solve this problem perfectly well is by actually saying, or by actually calculating this angle in here that the displacement makes with the west. And then the proper way to speak about the direction of this displacement would be saying something like, let's suppose this is 30 degrees. The direction would be specified by saying at an angle of 30 degrees to the south from the west. This is technically the way in which the direction should be specified, at an angle of 30 degrees to the south from the west. Can you see why I'm saying that? Now, for the purposes of this course, we're not going to need to be very specific about that direction. So even though this is technically the right way to do it, we're not going to do that. It's enough to say southwest or somewhere between west and south. That is good enough for the purposes of this course, even if it's a little vague, un poco vago. Okay, so that solves this problem, guys. And the next one is going to be very similar. We have a woman walking through the streets. She walks 100 meters east, 200 meters north, and finally 50 meters west. Find her displacement traveled and find her distance traveled and her displacement. So it's pretty much the same problem. Pretty much the same problem. The only difference is that now we have three independent motions in succession, but other than that, it's the same problem. So this is my frame of reference. This is the woman, or the particle I'm talking about. Now I'm gonna move the woman 100 meters east. Remember, this is the east, so I'm gonna move her 100 meters, represented by this arrow. Then 200 meters north. It's gotta be a little longer. 200 meters north. And finally 50 meters west. So since the west points towards the left, this woman would walk in this direction for 50 meters now. There you go. So the woman walks in this way, and she's gonna stop right here. So this is the initial point of the motion, and this is the final point of the motion. Now let's draw the displacement first. Let's draw the displacement of this woman. It's a straight line or a straight arrow going from initial to final points. Well, that's not. Well, I'm gonna keep it that way. This is supposed to be a straight arrow. Okay, so let's answer now the questions. What is the distance traveled? It's just the sum of all of the independent motions, 100 meters plus 200 meters plus 50 meters. So you will be looking at 350 meters. That's it. It's a scalar quantity. Now the displacement. The displacement is the length of this blue arrow from initial to final points. So how can I find that? How can I find the length of this arrow? Let me try to draw it a little better. How can we find? It's complicated. There you go. Well, the way in which you can find the length of this arrow, guys, is by trying to form again a right triangle. Look, what if I drop a perpendicular from this point towards the x-axis? I'm gonna drop this perpendicular. Look, there you go. And since this is perpendicular to the x-axis, then this is a right angle. So we have in here this little triangle in here. Can you see? And we can see from the geometry of this diagram that this segment, this dotted segment, measures the same as 200 meters, right? This and this measure the same. So this little bit is 200 meters. There you go. And how much is this bit from the triangle, or this side? If you notice, Since the woman walked 100 meters in this direction and then upwards and then 50 meters in the opposite direction, then this bit should be 50 meters according to the geometry of the problem. Try to understand why. This bit in here should be 50 meters. So that's it. We have all the ingredients to calculate this hypotenuse from this triangle, which happens to be the displacement. We have a triangle with sides 50 meters, 200 meters, and I'm looking for its hypotenuse. So x squared will be equal to 50 squared plus 200 squared. I'm ignoring the units. So how much is this? Let's do that in the calculator. That's going to be 42,500. And finally, we get the square root of that number to get a total of 206.15 approximately meters. Okay, so that's it, guys. The displacement is equal to 206.15 meters approximately. And in what direction? In what direction is this arrow pointing? This arrow is between north and east, so we can say northeast. That is enough. Remember, this is not very precise, but for the purposes of the course, this will do. This will be okay. You can also say somewhere between north and east, or in the first quadrant, something like that. There are many ways in which we can talk about the direction of this particular arrow. So that's the displacement, guys. And that's how you solve these problems. I hope you found this helpful. And now let's get to do the homework, which I'm going to post in a moment to your teams. Thank you, guys.